Hello everyone, Reza here. Welcome to another Unreal Engine tutorial. Today we are diving into the Scratch module in Niagara VFX, a powerful custom node that allows users to script unique logic and calculations for their particle systems. This session is packed with tips and tricks we've never covered in our previous tutorials. By the end of this video, you should feel confident enough to start creating similar effects in your own projects. So let's get started. Alright, let's dive into Niagara and explore Unreal's real-time effects tool. So far we've had a number of tutorials on Niagara system in Unreal Engine, and for each tutorial I try to bring something new, something to explore on, an opportunity to learn. In this project, I'm using Anthro Tiger Rig by Trevitol. I posed the character in Maya, then imported the albedo map and normal map. I made an emissive to make the eyes pop. Nothing too fancy really, just enough to get started. Alright, first step, setting up our Niagara system. So let's create a folder for that. And I'm going to right click and go into Niagara system. The UI changed, I think after 5.4, but rest assured everything is pretty much the same. So just the UI that has changed with some categories, but apart from that, we get pretty much all the keynotes that we need to be mindful of. I perhaps start with a template. Fountain, Niagara, emitter, and this comes with the emitter, so I'm going to go OK. I'm going to call that Niagara system underscore effects, and let's double click on that. That's the type of template that we want to work with. Now, few of these guys I really don't need. Few of them I perhaps disable for now. We're going to start with bare minimum. So spawn rate, how many particles we are going to spawn. We definitely want to crank this up a lot. So perhaps the first thing that you need to be careful about is whether you're simulating with CPU or GPU. I'm going to go GPU, compute sim, if of course your graphics card allows. And for the calculate boundaries, I'm going to switch to fix to get rid of that warning. I am going to increase the bounds because according to the effect, the particles are going to go up and I do not want to hit any limitations in there. So maybe 1000 to 1000 to 1000 to X, Y, and Z for min and max. That should suffice. And now I'm running on GPU. I can comfortably go into spawn rate and put in, I don't know, 10,000 or 50,000. What else do we need to change in here? So initialize particle is something that you always have. This module is a must-have. We never delete it. We just alter the values. But right now I don't have anything. I don't know what to change. Shape location is sphere, but we want to basically bring the model in. You may have noticed that this shape location doesn't have mesh. So that's the first challenge. How are we going to bring this tiger in here and put the particles on the mesh instead of defining a region, an area like sphere, cylinder, or box? So first things first, I'm going to get rid of that. Now add velocity in cone because it was in line with the location, the sphere location, which we no longer need. So instead of in cone, I'm going to set that to linear, but we are going to deal with that later. Linear basically gives it a direction like X, Y, and Z. How would you like you to have an impact, the initial velocity, the initial push on the particles once they create it. Let's go down. Particle state is definitely what we need. Gravity, it's a bit too early. It can be misleading and change the behavior, so I don't need to see it now, but I will be perhaps using it. Drag, I don't need to see it. And solve force and velocity is something that we need, because eventually down the road we are going to have drag and gravity force, and this guy is a prerequisite to get these guys working. With the sprite render, we're definitely going to make some changes, especially with the material here. But for now, I'm going to leave that as is. One last change is perhaps I'm going to single click on this fountain name, and I'm going to call this NE at the beginning, Niagara emitter. All right, that should do it. Let's go to the next chapter and come up with an idea to place the particles on this guy right here, because right now there is no link between my emitter and the mesh. Not only we need to do that, we also need to make sure that any particle that comes out of this geometry or generates from this geometry needs to inherit the colors as well. So if this area is orange, I really would like that particle that gets generated from this area to be the same color. Same with this area, same with this area. So white, blue, red, orange, so on and so forth. And we can do that using Scratch module in our Niagara emitter. Before we start creating a Scratch module, let's talk about it. See what a Scratch module is and where we need to place it. Do we place it in the emitter update, particle spawn, or particle update? Now, we want to change the behavior of our particle at creation. So we are going to use it under particle spawn. And there are times where you want to change the behavior of your particle after creation, and in that case you use it in the particle update, but for now we're going to use that in here. But what is a Scratch module? It's basically a module just like these guys, but we are going to create it. It's a custom node where users like yourself can script very unique logic and calculations and write custom expressions if need be. And with that, you can create highly flexible, unique effects. Now, funny thing is, Scratch modules are often used when built-in modules are insufficient. So you don't use it all the time, you use it when you want to create a particular effect. In our case, the effect that we want to create is to generate particle from this guy, and on top of that we want the particles to inherit the color of the mesh as well. And we don't have any module to do that for us. That's why we're using Scratchpad module. Where to find it? We go all the way at the bottom and you can see new Scratchpad module shows up. If I click, it creates a new tab right next to my emitter window. We're still in the Niagara system. So we usually get 4 nodes or 4 functions rather as your main building block. Your input map and output module, which you barely change, to be honest with you. And then you have the sandwich bun, as I call it. So the top bun and the bottom bun, and the material of your sandwich goes right in the middle. Hope that makes sense. Now, the getMap function is used to retrieve data. What exactly you would like to improve on. So you need to give it a source. In our case, the source is the static mesh. So let's go and type in static mesh. Under data interface, static mesh shows up. Feel free to rename it. Since I'm going to work on the static mesh, I'm just going to leave the name here. And anything that you create here will show up in your Scratch module details panel. That's another thing. So another rollout, and then you can basically drive the values and attributes from the Niagara system without going back and forth between Scratch module and system overview. So static mesh it is. The next step is to somehow tap into the polygons, or I should say triangles, because, well, it's all about triangles in Unreal Engine. Retrieve them, get its coordination, and feed that into map set. Just like map get, map set is going to write key value pair into a map in the Niagara context. So anything that you put here, you get it processed here, and it's going to output it here. So what we're going to work on, we are going to actually focus on a really useful function, which is particularly popular when you work with static meshes, and that is get triangle. Get triangle retrieves triangles from the input mesh based on its index. So that's just a perfect function for us to use. I'm just going to type in get triangle, and it's going to say, okay, I have a static mesh that's already been established. What do you want to do with the triangles? And what do you want to do with barycentric coordinates? And these guys are mathematical system used to represent a point within a triangle using u, v, w scalar values, basically. Now, at the end of the day, anything that we create, we want to connect that to our particles, to the position of our particles. So position of our triangles need to go into position of our particles. So I'm going to go and type in position, and we have different types of position. We have particle position, which is just the right fit for us. You can see even the colors do match. So I'm going to connect that in here. Now, although we have this guy, if I go ahead and save it and bring it in here, I'm going to centralize it as well. We're not going to get anything because I don't have the nominated model, and unfortunately nothing still shows up in my Scratch module. You can see it's empty because we need to do a little bit more work into this. So the next step is to specify triangles and target them. Right now we have the static mesh. We haven't done anything about these triangles, and that's why nothing shows up in the details panel. So in order to get the ball rolling, I'm going to use the same static mesh source, but this time I'm going to do random triangle. Why this random triangle is useful is it allows you to put the particles on the triangle and evenly distribute that over your mesh. Usually your mesh has areas with high density like face, like fingers, and areas with low density like chest or thigh, and you don't want to have more particles in one area and less particles in some other areas. You want even distribution of particles over your character, and that's why random triangle is extremely useful. So I'm going to connect these two to these two right here, and I'm going to apply, but it needs information about the triangle count. It's going to say, okay, I have the static mesh, but can you provide me with a value, with a container, so I can count the number of triangles, and I put that into the container so I can actually distribute particles on those triangles. And if you think about the number of triangles, they are integer. They are whole numbers like 10, 50, 20, 2000, so on and so forth. So they are integer. We need to have an integer to give that to the information channel so this function can do its job. To do that, I'm going to go int for integer 32. Now this little function is our triangle count. So I'm going to type try count. This is for indexing integer-based calculation. In our case, triangle. So I'm going to go from triangle count into random info and say, there you go, you have it. But before I connect, you can see something pops up. Convert int 32 into Niagara random info, and it's going to generate a brand new node for us. Why? Because it says, well, I have an integer and I would like to break it down into random information. It gives us this value with seeds, which they are in charge of randomization. And we are going to say, thank you. You're doing one more step for us for free. And with that, we should be able to be all set. I'm going to apply. And I think it's a good time for us to go ahead and nominate the model that we want to represent as our static mesh. If I switch to System Overview, we should be able to see our static mesh rollout and triangle count rollout. Let's go back. You can see we've got this little warning here, says, what are you talking about? There's no mesh. Not to worry, we're going to address it. But if I just look at here, you can see static mesh, try count, and if I go into my Scratch module, we have static mesh and try count here as well. Now we need to give this a proper value. We need to think about how many triangles we have, and we need to put that here. Then it's going to have the data it needs. It's going to randomize it, scatter it all over the mesh that we need to also specify in the static mesh. And with that, we're good to go. You can see the logic behind Scratch module is not too complex. You just need to clearly think about what you want to do, what your aim is, and then know about some of these nodes, and it will get the job done for you. This script is not really a complex script, as you can see. So I don't want you to feel intimidated by this Scratchpad module. It's actually fairly straightforward to use, very easy to use, and you can do magic, really create bespoke logic and calculations with it. All right, let's go ahead. Enough me talking, creating or rather connecting our mesh in here. So I'm going to go into my content drawer. Let's find our tiger, the static mesh. I'm going to go in here. Technically, this warning should go away once we connect the mesh to the preview and default mesh, and sure enough, it's all gone. I'm going to save. Let's go to try count. Let's think about how many triangles we have. I'm going to double click on the model. The triangle, nanite triangle, 8,536. Let's randomize it actually. Random range integer. So 0 to 8,536. Just double checking. 536. I'm going to go 535 because we have minimum here as well. And just like that, we are getting something. If I go into scene preview and get rid of the background and perhaps tone down the background solid color, you should be able to see something. I'm going to save, going to main, but you are going to notice that these particles are white, and they're white because the sprite renderer uses a white material. So first things first, we need to give it a proper material so it reads from the geometry. And because it needs to read from the geometry, we need to change or rather improve our Scratch module. It's fairly straightforward, so let's do that before we get to the next chapter. I'm not going to alter directly on this guy. I'm going to duplicate it. We always want to work non-destructively. So for this one, I'm going to go tiger underscore dynamic. That's better. So this is the one that we are going to give to the sprite renderer. I'm going to select that actually. Let's do that before we forget. We select our sprite render and say, use this one instead. But this is not quite ready yet. Although we see orange particles as opposed to white, if I look really closely, we're actually using the map, the whole albedo map instead. That's definitely not what we want, right? So let's go and make some changes to the material itself. So I'm going to bring that over. I'm going to create a dynamic properties or dynamic parameter rather, and make float 2 because we are going to connect that to UVs. So X and Y go to this UV and this UV and this UV. Perfect. So this works perfectly fine for what we want to do. But let's go ahead and change the scratchpad module as well, because, well, we need to make sure that once the static mesh is in between the bun in here, we need to have the necessary modules to get the ball rolling and to be able to read from the geometry as well. So let's zoom in. I'm going to again use the static mesh. We always want to use the same input. And this time I'm going to go get triangle UV. Now the get triangle UV retrieves UV coordinates or texture coordinates for a triangle on a mesh. And that is used in effects where particles need to be mapped to a specific region of a texture applied to a mesh, which is exactly what we're looking for. We want to have evenly distributed scenario that we talked about as well. So the triangle again goes to triangle and triangle goes to berry chord, and it's going to give us a converter to convert the content for us. Okay, where do they go? Are they go in the position? Actually, no. They're going into the dynamic parameter that we just created, right? So let's go ahead and create dynamic material parameter, like so. And UVs will go in there because we made these guys to be connected to UVs, and we are syncing the two, so it's not going to give us any inconsistencies or discrepancies. And the reason that this little guy shows up, because UVs are 2 channels, UV, but we need 4 channels, W included, or RGBA. That's why this conversion always pops up and converts vector 2D into vector 4. All right, that should do the trick for us. We are going to apply, and as soon as I apply, it looks at the UV or texture coordinates and it's going to sample the color for us. And now you can see any particle that gets generated is going to be based upon the area, the region, the specific region. And to do that, we definitely needed that get triangle UV. Good news, our job for scratchpad module is done. We're ready to go into the next chapter where we bring these particles to life. We add a little bit of life into them. We change their size. We change their lifespan. We're going to give it velocity, little bit of chaos, turbulence. We have a lot to do, but first things first, we wanted to make sure that the particles look right, which we accomplished in this chapter. Let's go to the next chapter. Okay, just a recap. We managed to generate particles from a static mesh using random triangles and get triangle. And we then managed to bring in a dynamic parameter in our material connected to our UVs. And then we use get triangle UV to sample from the color of our static mesh. So our job is done with our Scratch modules. And you can see I'm not dealing with too many modules. This setup is perfect every time you want to assign a custom material from a static mesh and generate particles from the same mesh. Try to memorize this, pretty useful. Now let's go and do the fun part where we look dev the particles. Obviously, they're very bulky. They're too big. The longevity is off. They're popping. No forces applied to them like gravity, drag, or turbulence. So we need to fine-tune the look of our particle system. First things first, I'm going to go in there and increase the number of our particles to 1,000 because, well, we really don't have too much or too many particles to deal with. So 1,000 for now, but I'm 100% certain that I'm going to increase that to a much higher value. Now let's start with our initialized particles because I feel like not only the size is off, the lifetime is also off. I want them to be very random, die very soon, and some of them live a lot longer. So perhaps 0.2 to 3 should do the trick. And in order to see what I'm dealing with, I really need to have some sort of a velocity applied. So let's go ahead and add velocity to it so we see the movement of our particles. So right now it's only pushing them up. Yep, as you can see, what I want to do, and this is totally based on your scenario and your taste, I want to push it a little bit in X and more in Y, and perhaps the same value for Z, which is the up axis, works just fine. So let's go in there perhaps, and again, these are the values that I'm just contemplating. Maybe I'm going to change that. So -100 and 200. The reason I'm putting minus here because I want these guys to be pushed this side, right? So if you want to push them on the other side, you put minus. This is perhaps a bit too low and this is too high. Maybe 175. And let's see. That's better. At least we have some sort of a movement to deal with, and then we can basically plan based off the look that we're getting. Okay, initialized particles. We were there. We don't want any mass, so I'm going to turn it off. The particles are way too big, and that's not what I want really. So perhaps let's start with there. I'm going to put 0.1. Some particles are really small, and 12 is very high. Maybe 5. Even I can reduce it down to 4, and that should give me a good result. Also, these particles don't linger enough. That's better. That's the type of size that I'm looking for. I'm gonna immediately jump back to spawn rate and use 10,000 instead. That's better. Now, right now, I'm getting the emission from the entire mesh, and that's not what I want. I want to isolate it. I want to specify a region and say only emit from the arm and the fingers, right? So to do that, we have just a perfect module called kill particles in volume, and it does exactly what it says. It creates a region. Anything outside the region is going to be killed. Anything inside the region is going to live. And we just need to make sure that the region stays in anywhere that you want in your project. In my case, it's the arm and it's the hand. And again, the idea is to create that disintegration effect. We're again not disintegrating the model, but the beauty of this effect is you can actually add that as an additional layer on top of changing your material, if that's the point, or changing your model, if that's the idea. That can be a perfect complementary effect. So let's bring that in, and I'm going to do that in the particle spawn. So it's called kill particles. Not just kill particles in volume. We want to give it a range, a fall off rather. And that fall off at the moment is sphere. It can be a box, it can be a cone, it can be a plane, whatever you specify. And then you can offset it, move it to the side, move it up, or what have you. So I want to invert the volume. So this volume right now, this sphere, invisible sphere, is now here. Let's move it up and to the side. To the side is Y, as you can see, and up is Z. So let's do just that. Perhaps 350, and nothing is showing. Perhaps because the radius is off. Maybe it's around here and we have no geometry. Let's find out. So 300. Now they're showing up. See, you can see that this side is no longer affected because perhaps the sphere is around this area. I need to move it up a little bit higher. I don't mind getting that disintegration effect a little bit on the outfit and on the tail, just a tad, but the focus should be on the arm. So perhaps I need to bring it up and to the side more. I'm just going to ever so slightly increase the size of the sphere, and that should really do it. That's good. Let's just put other modules and see if that holds up. If not, we can always go ahead and change it. Now, with that done, I think whatever we need with the particle spawn is all sorted. I'm going to be brave. I'm going to bump it up to 50,000. That's better. Now you can see there is no force. It's just pure velocity pushing the particles. We need a little bit of gravity, and more importantly, we need turbulence. So let's do those really quick. I'm going to add both of these in here. We actually have a gravity that we deactivated previously right at the beginning of the tutorial. Let's check the values. Oh, it's pushing the particles down. So we need to move this up ever so slightly. So we are going to use 150. That's too much. Maybe 100 for that. And of course, we need to have turbulence as well. So let's add turbulence, which is curl noise. So typing curl noise force, bring that in. Now we have noise strength, these waveforms, how far they go up and down, and the distance between each wave, which is noise frequency. You need to tweak that based on your scenario. I'm going to go really high, doubling the value and narrowing the gap between each waveform. So maybe 20. I'm going to do some pan noise filled as well. A little bit to the side, just a tad, and moving it up ever so slightly. Let's see what we get. I'm going to go 400 to see what we're getting right now. That's perhaps too much. Let's go back to that original 200. Now, one problem I have with this effect is it's chaos. It's out of control. Every time you have something like gravity or velocity or curl noise and you want to slow it down a little, you use drag. And that module is pure magic. I'm going to enable it. We have the intensity. There is no rotation drag. We don't want to swirl it like a leaf. We want to just have drag to slow down and tame everything that we have. Let's start with 1 and don't go too high with drag. 1 already is a really high value. Let's have a look. See, it's coming together now. Perhaps we need to push that ever so slightly. So let's go to 2 and see what we're getting. That's better. Now, another thing that I noticed is these guys are going up and disappear. I want them to, these particles, to shrink in size and then die. So that's pretty easy. One really good module that can do that for us is scale sprite size. So I'm going to type in scale sprite size, and it dictates how the particles are going to die. They're going to start from 0 and gradually getting bigger, which is exactly the opposite of what I want. I can make use of some of these presets, and this is, by the way, linear. I want a little bit of ease in and ease out. So instead of using linear ramp down, I'm going to use smooth ramp down. That's a lot better. Let's see the result. Yeah, I can see that they're like amber. So they go up and they die. I perhaps need to add a scale color into the mix as well. We want to some sort of a gradual degradation in alpha as well. I'm going to use float from curve and make it also smooth. Scale, curve, alpha. Yep, that's a lot better. So you can see how gradually but surely we're basically adding to the effect. I perhaps want to slow down the velocity a little bit. So setting this velocity speed scale to 0.5. And now we're talking. Looks really good. Okay, I think that amount of change for one chapter is good enough. Let's go to the next chapter and make some of these particles pop. Now I'm going to duplicate this guy and just add additional modules in here just to have a little bit of glow in there. All right, the aim of this chapter is to make sure that some of these particles kind of pop. So try to memorize the look and see what we get right after this. In order to do that, I need to make some changes to my dynamic material. So we have this guy here. Let's just really quickly create a few nodes, starting with Fennel. Bring that in and give it a little bit of power. Perhaps we give that more intensity. So then we can just hold down M, left click, multiply, and we want to sample from this color right here. So I'm going to move this ever so slightly back so we have a nice graph going on. Nothing is too crazy. Plug that in, and then I really would like to sort of apply that to my emissive. I'm going to hold down Alt, disconnect this. We don't perhaps need this. We're going to create another multiply, and that multiply goes directly into emissive, and we create a particle color because we want the particles to pop, and the only way to connect the material that you're using for your sprite to the emitter is by applying this little guy here. So this goes into B and A goes into in here, and we should have our setup ready to go. I'm going to move these guys down so it's easier to read. I perhaps can create some sort of a node so I can make this graph nice and clean. Also for my albedo, I'm going to create another multiply and basically disconnect what I have coming from my RGB, connect that to B. This goes into my base color, and again A is going to read from this guy, which is our particle color. So basically what I'm trying to do, I want my particle color to be in charge of the intensity and the color of our sprite. That's all I'm trying to do. And these guys are here to basically boost the colors. That's all there is to it. Hope that makes sense. You can see the colors are already a little bit more vibrant and brighter, but let's select this, press Ctrl D to duplicate this, and I'm going to call that camera offset. And you will understand why I call this camera offset in a second. Now, first thing I need to do, I need to switch to colors, and now this guy is connected to my base color thanks to the particle color module. I'm going to bump this up really high, maybe 50,000. Call me crazy, but I'm going to bump it up to 50,000. Worst case scenario, we're going to change that. No issues, no problems. No need to panic. I'm going to change the lifetime a little bit since these are brand new particles. Let's go with 0.1 and 0.5. For the size, I'm going to start with really small and perhaps 3. That should really do it. And one node that I really would like to add, before I add that, let's have a look. You can see now these particles are kind of glowing, which is really cool. Perhaps I went too far with those. 30,000 should be enough, perhaps. We'll see how we go. We can always change those. But one really useful module that I always use in scenarios like this is camera offset, which I apply it to the particle spawn. So if I type in camera offset, and the beauty of this module is it adjusts the position of particles relative to the camera. So basically it says whatever particles are here, it's going to say, see me, see me. So something like this, and not with that voice, of course. I'm going to reduce the number of particles on this one because we already have 50,000. We don't want to add another 50,000. We want some of these particles to glow, not all of them. So something like that. Now, right now you can see some of these particles have got high values in intensity. Look what happens when I go into camera offset and change this value. I perhaps need to randomize it as well. So random range float is going to get the job done for us. I'm going to start with 10. Let's see. Zooming in. Bump it to 30. Now we're talking. Some of these particles that are now glowing are facing the camera. So we're actually seeing these glowing particles better. You can add bloom to it. You can add effects, change your exposure, however you like it. And you really bring these to life. These are great tricks if you want to create fireflies, let's say, in a dark environment, outdoor environment or indoor environment. And that should really do the trick. So I think we've done enough to get the look that we want. I'm just going to have a look at my final result through the lens of the camera. Now, because I'm going to go and switch to in here, we want to make sure that determinism and local spaces are on. And because of that, I can easily select both of them, the particle system and the tiger, and I can move it around however I want to. And you can see they both following as well. Well, mainly to the local space, but determinism is going to bring a little bit of consistency into the mix as well, which is always nice. Now, the only issue is the light that we had is no longer valid. It's not in the right position. I gave it a very controlled fall off or attenuation. As you can see, attenuation is 60, so it doesn't have an impact on our main character, but of course in your own scenario you deal with it however you want to deal with it. That's totally fine. It's more of a artistic decision than anything else. And with that, my friends, this tutorial comes to an end. Hopefully there was an opportunity to learn a few bits and pieces. These tutorials are just excuses for me to share more tips and tricks with you about topics that we haven't covered in this channel. So I hope you found this trick useful, and I truly hope you use these type of effects in your own projects. Let me know in the comments below, and as usual, thank you for your ongoing support. All right, until the next tutorial, see you guys later.